hello, everybody. Good morning, folks. My name is Jesse. I'm here with Exploring by the Seat of Your Pants, and I know we've got some new faces in the crowd today. So if you are new to us, we are all about bringing conservation, adventure, and science into classrooms around the world. Now, you're catching me on a very exciting day, and it's very exciting for a couple reasons. Number one, it's February. It's our entire month solely dedicated to showcasing the most amazing women in science and exploration on planet Earth. We've been doing this since our inception over 8 years now, all in commemoration of February 11th, the International Day for Women in STEM. So I really encourage you, check out our YouTube channel. We've got so much on the go this month to come. We've done so many programs in the last few weeks, including our Epic If Then series. So lots to explore and discover with some really amazing people and some really amazing places around planet Earth. And number two, it's really exciting because we are doing a space program again. We've done a lot of conservation lately, and I love conservation. It's my favorite topic. But I'm so excited when we get to dive back into exploring space exploration in any fashion, whether it's discovering Mars in the Canadian Arctic, as we get the chance to do today, space robotics, astronauts, and more. And I want to recognize that Western University's Institute for Earth and Space Exploration has made our entire space series possible this year. They do so much to communicate to the public the magic and wonder of space science. So do check them out. We're going to be linking in all our registered classes with all sorts of neat resources to keep the learning going when we're done. But without further ado, I'm bringing in all-time veteran of Exploring by the Seat of Your Pants, Cassandra Marion, who is going to talk to us about an expedition she's had the chance to do for the last couple summers up in the Canadian Arctic, discovering Mars. How do you discover Mars in the Canadian Arctic? What are the landscapes like up there? What kind of teams does she bring to the fray? I'm so excited for you to learn as much as I will today. And without further ado, Cass, welcome back to the program. So nice to see you again.
Hi, Jesse. Glad to be here.
I know you've got a lot to share with us, so I'm going to zip my lip and leave it to you to blow our minds over the next 20 minutes or so, and I can't wait for all the questions at the end.
My pleasure. All right. Hello, everyone. Hello from Ottawa. So a little introduction. Basically, I'm a planetary scientist and a geologist, so I love rocks and space. Right now, I'm wearing the hat of science advisor at the Canada Aviation and Space Museum in Ottawa, which is just such an amazing job. And through that, I got to go participate in these series of expeditions and now get to share them with you. So in the last 2 summers in July, I participated in and led 2 3-week expeditions to Axel Heiberg Island in Nunavut. And I had a few roles on this expedition. I was asked to lead because I'm an experienced Arctic scientist. This is actually my 12th and 13th expedition to the north. But I also acted as support scientist and drone pilot, and of course, documented everything to be able to share it with groups such as yourself. And this is just a view from my tent to give you an idea of what I got to wake up to every morning and go to bed to at night. Except for nighttime there, it's still bright. How did we get there? I'll start with the where. We're at 79 degrees north. So most of our team came from southern Quebec and Ontario. So we all grouped and found our way to Ottawa. Then we took commercial flights from Ottawa to Iqaluit, then to Pond Inlet, Arctic Bay, and Resolute Bay, where there's the Polar Continental Shelf Program, basically a logistics or managing all of your gear, food, and flights to get a charter flight on a Twin Otter, which is sort of a bush plane, a cargo bush plane that takes us the rest of the way north to what we call the TMARS base camp. TMARS is the name of our project, so you'll see that a few times in the presentation. If I zoom in on these Arctic islands, this is Axel Heiberg Island here, and this little box is our study area. So on that little box study area, we're down Expedition Fjord that was created by these beautiful glaciers here. This is White Glacier and Thompson Glacier. And the first expedition, we were camped right close to the glacier at camp number 1. And then halfway through, we took a helicopter and moved our camp to camp number 2. And in the second expedition, we camped at what's called the McGill Arctic Research Station. Now, the McGill Arctic Research Station was founded or established in 1960, and there have been researchers there almost every single year since from all sorts of different forms of science. But it was really established so that it could monitor White Glacier, and this is one of the best monitored glaciers in the world. I'm not going to talk too much about it anymore, but if you have questions about it later in the questions, feel free. So zooming in on the McGill Arctic Research Station, you can see that there's a couple of solid structures. This is a laboratory. We call it the upper hut, and a couple of bunks in there. There's another one sort of down the hill. It's the oldest structure that's there. There's also this other structure. It's a kitchen. It basically, the whole camp runs on either solar power, and then the kitchen itself mostly runs on propane. There's a couple of weather havens for storage, and some people bunk in there, but most of our team stayed in expedition tents. This is my tent here that you saw the view from a moment ago. This little trail here goes all the way around the mountain, and that is actually our bathroom. It's the bathroom with the best view in the world. You do your number 1 on the ground and your number 2 in a bucket, and then once a week, the bucket contents get incinerated. And the view is looking out to the west, and that's the ice on the fjord, and that goes into the Arctic Ocean. Now, what's really special about this area and the McGill Arctic Research Station, it's conveniently, the acronym spells out Mars, but not just because of the acronym, but because this site is wonderful for analog Mars studies. And analog studies just means studies that take place on Earth in environments that are very similar to environments on Mars. So we basically study Earth to better understand Mars. And we can do this in a variety of ways, and this particular study does do that, and I'll get into details in a moment. But if you're thinking of Arctic in general, not just this site, but many places across the Arctic islands can be used as Mars analogs, because the Arctic is a polar desert. It's cold. It has very little vegetation. There's permafrost, so the ground is permanently frozen all year round, except for in the summer, just the top layer, maybe a meter to up to 2 meters, thaws and then refreezes the next season. So it's also very remote, but it has very similar geologic environment and features to things that we might find on Mars. And in those environments, of course, we could also study life living in extreme environments to give us a better idea of where to look for ancient life on Mars. And working in this type of environment, it's remote, it's dangerous, but you also have to do some important cool science. And that makes an Arctic expedition a great place to simulate an actual space mission and test out actual space technologies. But that includes training actual astronauts as well. So all 4 of our Canadian astronauts have now completed at least one northern expedition, not to Axel, to my knowledge, but on other Arctic islands. So on Victoria Island and on Devon Island and in Northern Labrador. And some of those expeditions I was fortunate to be a part of. So I'm just this is a little astro plug. But Joshua Kutrick, who I got to help on an expedition with Joshua Kutrick and Matthew Dominic. Josh he got assigned to a mission to the ISS, and he'll be launching next year. And Matthew Dominic is on a mission to the ISS in a week and a half. He's leaving for space on the International Space Station. He'll be there in about a week and a half. And of course, I can't not mention astronaut Jeremy Hansen, who's now done 5 of these geo expeditions and many more different types of expeditions through his training. And he'll be flying around the moon. He'll be the first Canadian to go beyond Earth orbit, and he'll be flying around the moon as early as September 2025. And I have to say that working with astronauts in the field, they make amazing teammates. And so speaking of teammates, I'm going to flip back to my Axel crew. These are our teammates from the both expeditions. We're spelling out T-Mars. But we're basically made up of a team of remote sensing scientists. Those are scientists that study things at a distance, geologists, astrobiologists, so people that look for life elsewhere, and includes 4 master's students who really did the bulk of the science. And though I was the field lead, the science lead and the project lead, or the principal investigator, is Myriam Lemley right here, and she's from the University of Sherbrooke in Quebec. Also collaborating is Richard Levier. He's a professor at McGill, and Marie-Claude Williamson from the Geological Survey of Canada. So what is this whole project about? Gossans. That's our feature of interest. But what is a gossan? It's basically rusty orange rocks that we can see at the surface that represent what's hidden underneath. And so the rocks underneath, when they are iron and sulfur rich, they get to interact with groundwater or acidic or warm fluids in the ground. And then there's chemical reactions that generate sulfuric acid that dissolve those iron minerals and reprecipitate new ones. And basically, you can also see this same type of reaction happening, when you see rust on a car. And that rusting, the scientific term for that is oxidizing. So you're getting interactions, adding oxygen to these iron rocks and breaking the iron minerals down. So you can see two examples. There are some gossans up here. You can see it's all orangey up top of this cliff face, but that was a little bit too challenging to reach. And there's also a sort of a gossanous soil here. But when you dig a trench, when you dig down into the gossanous soil, you actually get this vertical layering. And so you get the most rusting effect or oxidation at the top and less at the bottom. You also get very acidic soil at the top and less at the bottom. Now, what's special about these gossans in the Arctic is that they're being reactivated by the freezing and thawing of the permafrost. It's acting as a pump that is pumping new water through very slowly through the seasons. And so you're still getting all of these alterations happening, whereas the rocks that are being altered, they're millions of years old. And so they're still reacting today. And that's something that may have been active on Mars in its distant we don't know how long ago past. But this is significant because you've got an active geological deposit. It's nutrient rich, so there are bacteria and microbes that really love iron. It's water-rich environment, and so that makes it a potential habitat for microbial life. And so they're a place to look, this type of feature on the surface of Mars, for ancient life on Mars. We haven't found gossans on Mars yet, but what we have found from orbit and from rovers, we've identified similar minerals on Mars that we find in the gossans and in gossans, the gossans that we found in the Arctic and analyzed. And it's also suggesting that these deposits are part of what's called ancient hydrothermal systems on Mars. And these are something that we also have in the Arctic. So we can compare the two. The difference is any of these deposits on Mars probably formed in Mars's distant past when it was more water-rich environment. And now those deposits would be enclosed in a very acidic permafrost because, of course, Mars is very cold. It also has a permafrost environment. The challenge is that, we can see things from orbit and we can see things from our limited rovering on the surface of Mars, but we can't dig down and get those vertical the vertical view of what lies beneath. And so that's a challenge. So we're going to do that here in the Arctic to make some interpretations of what might be below the surface on Mars as well. So this whole project, the T-Mars project, has sort of a scaled approach. And we start with satellite information, and we interpret and we map gossans from satellite view. Then we do it on the ground, and then we do it in the laboratory, and then overall assess the microbial habitability. And so conveniently, gossans, very large ones in particular, can be seen from space. And so I'm going to give you an idea of what each of these steps look like. But basically, we map from space, and we interpret where the gossans might be. Then we go and double check our map in this sort of step 2. And we analyze, we map, we analyze for the composition of the gossans. We use all of our various instruments to zap it. And then we dig down and we do the same thing with every layer of the different soils that we find. And then we take our samples at each of those steps and bring them back to the laboratory. So on the right side here, you've got a geological map. Each color represents a different rock type. This is something that was made well before our expedition, but it's something to help guide us. And so there's lots of different types, but just to show you, there's lots of different types of rock types in the area, but most of them can also be found on Mars. And this is the image of our field site from the satellite view. It's called a Worldview 2 satellite image. And even though this looks like what it would probably look like with the naked eye, each pixel is actually full of information from a variety of light wavelengths. So we don't just look in the visible, we look across of what we call the electromagnetic spectrum. So wavelengths in, for example, the infrared. And we can take each of those pixels and we can reorganize the information with a special software to make certain rock types or features stand out, like Gaussons. So where to find the Gaussons? This is what that might look like. So one of our students, Eloise, made this map. It's so pretty, even if you don't know the science. But each of these colors, which are false color, represent a different rock composition. And she's made it so that the Gaussons stand out in bright yellow or orange. So you've got some on this cliff face here, and all along, this is Color Ridge. This is the Mars Desert Research Station is actually down here. This is that big lake. And so you can see, so most of our expedition, we spent climbing along this ridge and checking out all of the Gaussons that she mapped. So that looks like this. So this is me and myself and our team next to White Glacier. And you can see that very steep, very bright yellow spot here is shown up on this ridge. It was way too steep and too dangerous to cross the glacier, so we couldn't explore that one, but we did continue on. So you can see it's a little bit of a trek that way. We also brought with us some of the instruments we brought. This is a multispectral camera. That's the same type of instrument that was on the satellite that gave us the power to make that beautiful, colorful map. This is Levin and a remote sensing scientist. I got him to take a photo of our team too with the multispectral camera, and that's what it looks like. Just a bit of fun while we're doing our science. One of the most beautiful Gaussons we found, and this is just a perfect example of the layering that we can see not only at depth, but on the surface as well. So you can see they're sort of two-centered, and you can see the colors changes as it's going out. Sorry. And there's another one just here. And this footage was collected with I had a very small drone that I was piloting, but I had a really good camera on board. And so it really gives you this wonderful wide view. And every outcrop that we explored, we took similar footage and images. And that's something you really can't take from the ground. If I zoom back in, this would be our wide scale, outcrop image if we didn't have the drone, and you can't see much because you can't really back up because you're on the side of a mountain, right? And you can also use the drone, to go and explore other places that we might not be able to get to or scout ahead. So just examples of us in action doing those stepped approaches. So we first characterize the surface. We look at the composition. This instrument here, this is a reflectance spectrometer. And so it's using light to establish the composition of the rocks, similar to what we might get from satellite. And then we dig a trench. Once we're done on the surface, then we dig down and we do the same thing. And you can see that we put the instruments way down into the trench, and we analyze at each of those different colored layers. And of course, we document everything we're doing, and then we collect samples along the way. So samples for astrobiology, though, for looking for those signs of past life or biosignatures, they have a very special procedure because everything has to be sterile. So we brought special latex gloves, sterilized instruments, sterilized bags, and we even had a little procedure where one person had clean hands and the other had dirty hands to move and hand tools off so that there's no contamination in between the two. And then the other tricky thing is storage. You have to keep those samples cold. And so we actually made our own ice box with a patch of snow when we weren't at the station. And at the station, they actually have a solar powered freezer that we put the labs in. And I will tell you that the results of these samples did show actually there's a variety of biomarkers and microbial communities in these samples. So that's good news for looking at for life in Gaussons on Mars. We also, of course, mapped and sampled the general geology to match with our map. And we found that mostly the map is pretty accurate, but only on a large scale. Once you start getting very specific and down smaller than a pixel, then you get more variation that's not covered in the satellite. So it's always advantageous if you can get data on the ground as well. And so Mars, that's a bit more of a challenge, and then sampling on Mars, even bigger challenge. We also tested out the environmental impact of these Gaussins have on sort of, like, for example, the water sources in the area, and they're all much more acidic. So I mentioned that in those Gaussins, those chemical reactions actually produce acid. And that shows the whole region, all of these water sources are acidic. This is actually our drinking water, which is a pH of 3.9. And that's quite acidic for something to be drinking, but I still have all my teeth, so no worries. A little bit about how we got there. A few weather delays. The first expedition, we were kind of stuck for 8 days. Everything was grounded. But once we're in the air, Axel Heiberg Island is one of the most beautiful places I've ever seen. Just, and we're, of course, flying in the Twin Otter on the way there. So it's a 2-hour flight. This is the first place we landed, near Crusoe Glacier. And this is the landing strip that's right next to the Mars Desert Research Station. This is that lake that's very acidic. And of course, we have frequent meetings with our team to combine on science. And every Gaussin that we find, it really took every single team member to make this approach work. It took a lot of hands because we had a lot of instruments to carry and zap, and hand off. And so it was wonderful to have 2 amazing teams to work with on these expeditions. We also saw a variety of flora and fauna, lots of birds, which I didn't get great photos of. But my favorite, of course, is this Arctic hare. And he followed us around for a little while. And then we saw evidence of muskox. This is muskox poop and hair, but we didn't actually get to see them directly this time. No polar bears, with the exception of the stuffed one at the Resolute Airport, thankfully. And I just wanted to mention, while I was in the field, because it was July, it didn't work out to talk directly to schools, but we did do, thanks to space technology, a live camp tour, which is on our YouTube site, which has the same title. So if you did want that sort of additional tour of the project, you're welcome to go and check it out. And with that, I will say thank you for listening, and I look very forward to your questions.
Oh, Cass, that was amazing. Even by our usual standards, they're just like the best footage and stories ever. Like that, you get to go on the coolest expeditions of all time. So lucky you. And I will find that link for all our classes. I'll share that link to the live camp tour, but that sounds amazing. If you want to come out of screen share, I don't know how your setup is, but if you want to see me again, you're good. If you can't see me, fantastic. Our first question is about the logistics of getting there. So you highlighted the sort of plane route to the very far north. How long does that take? What's going on? It looks challenging.
It's a great question. So it takes, it takes 1 day to get from Ottawa to Resolute Bay, assuming no delays. So on our way in, we had to turn around because Iqaluit was fogged in, and we ended up in northern Quebec for a couple hours. But we did make it in one very long day. Then you take 2 days in Resolute, and you have to prepare. So you're rearranging your gear, you're organizing what's going on the plane and where, and you have to weigh everything. And we actually had to reduce our weight by 400 pounds and leave some gear there because we were over. And so that takes a lot of time. And you have to put up all your tents, make sure everything's together. So if you were to go direct, you could get there in 2 days, but you really can't because you have to do the organizing in between. So I'd say 3 days minimum, 3 to 4 days.
I still think this is an important thing for our kids to know. You can get to Australia in 15 hours, 24 hours at least, right? So it is still quite the adventure. It's one of the more remote places on planet Earth to get up there. And, the prep's a really important part. We've been talking about this all week long. Whether you're doing Arctic expeditions, deep sea, astronaut expeditions, the prep is immense. In advance, it's months of planning, it's figuring out all this thing, and then you end up having to reduce weight on your final stop at base camp, so to speak, before you go. So great question to kick us off, guys. And a question about the camp itself, and I think you might have talked about this at the beginning, but we'll reiterate it just in case. Are people there year-round, or is it only the summer that it's possible to be there? What's the deal over the winter?
Over the winter, it's 24-hour nighttime, and so You can't really get aircraft in there landing at night because there's no, lit up airstrip. It's really, you're landing on, even in the daytime, it can be very challenging to get aircraft in there, and the only small ones can land. So they do have people starting from the spring. Most of the glaciologists, they take their initial measurements early in the spring, and so they're there, I think, from April, May-ish to the first week of August every year.
Okay. Very cool. I love that you showcased the plane that you take to get there, and especially get on the ground as well. Like Twin Otters are like the most, just for our class's sake, like if you're going to any remote region of planet Earth, there's probably a Twin Otter involved. Like they're like the workhorse, awesome super plane. Every time Cass comes on, we get to talk about them because she gets to take them all the time. It's a fun vehicle. Very cool, guys. Great question.
Amazing aircraft. Yeah.
All right. So we talked about Canada today. When we're scanning the Earth with these satellites to try and find these places, do we find them in other countries? Are we even looking in other countries? Have you been to other countries? Like, is there any international element to this work or comparable scientists that go elsewhere for this around the globe?
For this, well, for Mars analog studies, yes. I mean, there are lots of places around the world that you can do for just general Mars analog studies. It depends, they're very specific. Each project is very different. But for the Gaussins that I talked about, Gaussins are actually really common. You can find them all over the place. But what's special is the Arctic is the Gaussins in the permafrost. And so there's very likely, there's no international component in this particular project, but you could go to other Arctic regions and find some to study.
Yeah, very cool. Great question, guys. All right, we've got one about dangers, because we always get one about dangers when we're out in the high Arctic. So are there dangers when you're out there, whether it's weather, whether it's potentially running into maybe polar bears or other wildlife that can pose a risk? What are the threats?
Absolutely. So there's a long list. If you want to start with polar bears, we can start with animals. So there's a variety of different wildlife that can pose challenges there. Polar bears are one. They don't commonly come up as far up as we were in the fjord, but they are everywhere in the Arctic, so they could potentially go. We do know that they're there in the winter because they messed with some fuel drums. While we were there in the expedition, not my team, but there was another team that had an encounter with some Arctic wolves. No incidents, but there was an encounter, and I have had encounters with wolves in the past. Muskox usually tend to stay out of your way, especially if they're in troops. Those are the main dangers. I mean, there are other animals, but usually if you don't bother them, outside of wolves and polar bears, if you don't bother them, they don't bother you. But there are just the regular dangers, like the terrain is, there are huge physical challenges. And so, if somebody falls down a cliff and breaks their leg, it's going to be first a challenge to get them from there to a place where you can get an aircraft in to get them some help or get them back to camp. And then, you can get someone back to Resolute, but there's still no hospital in Resolute. They have a medical center, but the nearest hospital is many hundreds of kilometers away. And that's the main thing, is if something bad did happen, getting the help to them right away is difficult.
Yeah.
And of course, weather, yeah.
Oh no, I'll stop talking. Tell me more.
Yeah. No, I was I'm just going to say, well, you saw the fog. So that's a challenge. It actually, it's a challenge to, like, if it's that thick of fog, we actually don't go out those days because it's too dangerous on that terrain, and you wouldn't be able to see dangerous wildlife that is also white coming at you.
Two notes on this. So one is the difficulty of getting to a hospital. So we talked to a lot of Antarctic researchers as well. And I mean, I think most famously ever, because it's just a great story, the doctor down at the South Pole base where they couldn't come in, like it was months that they were going to be down there before the plane came in, had to operate on his own appendix. Like he had to have help from non-trained medical personnel and like phone in and did that. And I mean, that is an incredible story. Hopefully you're never in that situation, but like that sort of underscores the challenges of getting to these remote field locations. The Arctic's one of the most remote on Earth, in the places that you're going. And so, on a quick segue before I have a question about the necklace, of course, and I'm so curious. Do you have to have rifle guards? Do you have to have people with you in case of bears or wolves? Because we've had this a lot before in the Arctic.
We don't have rifle guards. We have several team members, including myself, that have our possession acquisition license. We do bring up we brought up 2 shotguns. Our whole team, whether they have their license or not, basically day one, once our camp is established, everyone gets a gun safety training, as well as, animal safety training, all of those safety trainings. And so that even though they might not be the person handling the weapon, they're not uncomfortable having it nearby. And yeah, so pretty much every day someone has got a shotgun on them. But that's sort of the last resort. We actually bring a variety of deterrents. So the first thing is a whistle. Wolves, for example, don't like the sound of whistles. And then we also have bear spray and bear bangers. So we try and use those first. The gun is a last resort.
Don't get me wrong, it's important to highlight that, but it's also super cool that the first day of camp, we're like, let's do some weapon safety training and some animal safety training. It's amazing stuff that you're going to such a cool place that you need to do that is a necessity, and it's important. And it's worth noting, in our history as Exploring by the Seat of Your Pants, we featured a lot of scientists in really remote places. We've yet to have someone who's actually been in serious danger where this training came into play. There's a lot of prep that goes into this. Oh, unless what was that face?
Not on these expeditions, but I had to break out again with a wolf incident, but didn't end up shooting anything. It's fine. Everyone was good.
But there you go. I stand corrected, audience. Cass has been in the coolest situation or the most challenging situations of all time. Necklace note, because it was very shiny there as you were answering the last question. What is this necklace? And I need to highlight it for our kids because it's super cool.
This is the mirror on the James Webb Space Telescope.
It is the greatest sort of scientific device in the last decade. We do a lot of programs on it in September and October with Natalie Ouellette, who's an amazing science communicator. I really encourage our classes. Check out the James Webb Space Telescope if you haven't seen it, because it's very neat stuff going on. All right. I like this one. I hope we might get this one. Would you go to space? If you could go to space, we're discovering Mars in the Arctic. If you could go in a rocket, yes, 100%?
Absolutely, I would go to space. Sign me up. But there are limitations to that. It's not a yes, I would go anywhere, anytime. It was if I had the opportunity to go in space briefly, or to the International Space Station, or orbit the moon, I'd say yes. But I probably limit it there until we had a little more experience with landing on the moon and landing on Mars.
That's my exact answer. Someone asked me this the other day after I asked the speaker, and so yes, I'm with you. Let's test Mars out a little bit first. Let's have like 15 successful missions. I don't need to be the first. That's fine. Worth noting for our kids, if you guys are keen on space, like, you are the perfect age to literally be astronauts going to the moon and potentially Mars. Like, that is the timeline for this. It's like the new golden age of space exploration, which, I mean, my face hurts from smiling just thinking about it. So Cass is lucky to get to do some of the groundwork, literally and figuratively, for all this. But if you're keen, we've got a lot of other really cool programs on that. So thanks for the question, guys. All right. One of my favorites. Is there a favorite part of your job? This all sounds very cool. Is there something that gets you up in the morning? Is it the field work? Is it some aspect of the field work that you really love? What's the deal?
I do really love field work. It definitely is a passion, and it's what got me, to join the sort of the geology side of things early on. But at the museum, it's really fun to interact with the public and come up with new programs. The best part of my job is that I don't do the same thing every day. It's so dynamic. I'm either, in the Arctic on an expedition, or I'm working with the classroom, developing a new program, or I'm helping design an exhibit, or I'm interacting with partners and coming up with a plan. And so it's very, very different. That's really the best part of my job. And I get to do it all in the theme of space.
Which is very, very fun. I'm going to set you up for something on this theme in a second. So how much schooling did you have to get where you are? And this is important. If we're going to tie this back to what you just said. Tell us.
So I have 3 university degrees. The first one took 4 years. So an undergraduate degree in geology, a master's degree in geology, which took 3 years, and a PhD in geology, which took, let's say technically 6, but I had kids and I took breaks, so it took 8. So that's many, many years in school, and then more in between working different contracts.
So I have you say this because I knew that you had this educational background, and I think it's really important because it sounds so daunting. You're in grade 6, and the thought, okay, 6 more years, grade 12, and I'm done, and then a 4-year degree, and then multiple other degrees, and it's like, I'm going to be in school forever. And honestly, it seems really daunting I remember being a student, the age of our kids joining us today. But you know what? As you're doing those higher level schools, master's and PhD, you're doing the work that you're ultimately doing. You're already collaborating. In many cases, you're already being paid. Sometimes you're paid to go to school. And so it doesn't feel like school does now. And as you're doing it, at the end of it, you end up with a dream job where you get to go to the Arctic and talk to the public about these things and have every day be different and work with the coolest people on planet Earth in some of the most amazing places. So all I want to stress is that, becoming a scientist, becoming as amazing as Cass is challenging. It's very difficult. It takes a lot of hard work. You don't need to be a genius. You don't need to be as smart as Cass. You are great. But at the end of that, you get to live a really fulfilling, exciting, wonderful life. And so if it is something that you're passionate about, don't let that hold you back. And I think that's a really important message. So kudos for you.
I will absolutely agree with that. And I'll throw in that, some of these expeditions, and even one of the expeditions I was on with one of those astronauts and helping in his training, I was a student during those years. And so lots of really fun, really exciting things happening while you're studying.
See, when you're in grade 8, when you're a student, your projects are do this math lesson. When you're in your PhD, you get to be oh yeah, I'm going to train an astronaut somewhere far away in the Canadian Arctic on an expedition, so that when they go to the moon, they know what they're doing. Very cool stuff. And I wanted to stress, I'm going to plug, we did a program with you and Josh doing live astronaut stuff from the field. So if people want to check out our YouTube channel, look up Cass's name. We've done a whole bunch with her. She just keeps saying yes to me, which I don't know why she does, but it's always a pleasure having her on. So do check that out as well. Great question, and time flies when you're having fun. So we are nearing the end of the broadcast, shockingly. A question about if kids wanted to follow in your footsteps, if they wanted to do something like this, is there anything you'd recommend to students in school, anywhere from grade 4 to grade 11 today, that would help put them on the path to such a cool gig?
Sure. Well, definitely stick with your science and math classes. And then also I'd suggest, if sometimes you don't have to be a scientist to go on these expeditions. We had a teacher, sometimes we have a photographer. And so if you just want to get up to the Arctic, for example, there are a lot of different fields that you could be in, and you just have to be a collaborative person and someone that reaches out for opportunities that present themselves.
Yep. I think that's so important. And something that we talked about all last week in the If Then series is that, again, not all of you are going to want to be scientists. Great. Neither of us want you to all to be scientists. There's a huge role for artists, historians, photographers, business people, whatever. But if you want to be involved in amazing projects like this, whether it's a deep sea expedition or work at NASA or go up to the Arctic, there are a bevy of amazing possibilities for you. So just follow that and do it and talk to people. I mean, people, Cass, correct me if I'm wrong, if people talk to you and they wanted to pick your brain about cool stuff you're up to and get advice, you'd be so willing, as is evidenced by coming in on this broadcast. And that
absolutely. That's actually part of my job.
Even better when that's the case. But people are we've had 3,000 programs, and pretty much university scientists and explorers are really keen to share their enthusiasm, their passion, get people inspired like they were. So never be afraid to reach out. The worst you can get is no or a no answer, and then you reach out to someone else who is willing to talk to you. So
exactly.
Very cool. Cass, I'm going to do some plugs for some really cool projects for our kids right now, and then we're going to wrap up together with a final message bit. But as I said at the beginning, we've been partnering with Western University, showcasing some really exciting space programs. We want to say a big thank you to them. Their Cronin Observatory. Get to an observatory. I'm sure you were inspired by this too, but if you get to see space through a telescope, it is a life-altering experience, no matter where you have the chance to go. I saw Saturn's rings through a telescope. It was like a dot with a line through it, and it was profoundly moving to see that, as opposed to just in a textbook. So go explore. STEAM Labs, our folks there, Mission Control Space Services, does some amazing stuff, and the Engineering Outreach Team. Southern Ontario, a lot of our classes are from there today, has a huge bevy of amazing stuff in general. I grew up in Toronto, but wherever you're joining from, talk to your university, talk to your libraries. They'll point you in the right direction of some really, really cool stuff. So, Cass, with that, is there any final message about this expedition, about your Arctic work, anything you want to leave us with before we wrap up and say farewell?
Just stay open-minded, put all your effort into it, and reach out for those opportunities.
Cass, a pleasure as always. Thank you so much. We can't wait to have you back anytime you'd like ever. Just come back in a week. Whatever makes you happy, we're in. And for now, for you and our audience, I'll say thank you.